in this next example, we have the graph of y equals 1 half x is translated to produce this new graph below. Determine the graph. So for me to do this question, the very first thing I do is go straight to my graphing calculator and figure out the equation and what it looks like for a function of 1 half exponent x. I'm going to hit graph, and there we go. So I'm going to, just to help myself out, I'm going to graph this exact same graph on this grid here to see if we can pull out some coordinates and compare them between the two graphs. So I really want -3, +8, which is off the grid, -2, +4, and so at -2 I'm at +4. At 1, -1, I was at +2. At 0, I'm at 1. At 1, I was at a half. And at 2, I was at a quarter. And there we go. I'm going to connect my coordinates here. It should look like this for our original graph. Of course, arrowhead, arrowhead. So really, I'm going to pull out some coordinates that I think I can read. So I see 0, 1 on the y-intercept there. This one here would have been at 1 and that would have been a half. So again, you don't really want to use a fraction there. I'm going to go back one. This one here was at -1 and 2. And of course over here we had -2, 4. So we have a few coordinates there in the original that we can compare to. In our new, if I just zoom in on our graph here, let's take a look at which coordinates we can see. So we have a coordinate right around here, right here, and right here. So these coordinates are the following. So we have 2, -2, 3, -3, and at 4 that looks to be at -3.5. There we go. So we have 3 coordinates here that we're going to try to compare. So these 3, by the way, if I had a half, a whole, and another whole, that's going to be these first 3 coordinates. So I'm really not going to take a look at this top one here, so I'm just going to remove it. So I'm comparing these 3 to these 3 here. Well, whenever you're building a graph, you need to always run RST. So that means from your original, did you have any reflections first? Well, I didn't change direction. I didn't flip over the X or the Y, so I don't have any reflections. So I'm going to jot down no reflections. Let's double check our stretches second. So on my original, to figure out my Y or my vertical stretch, that's the one I always look at, I look at my Y values. And again, I look at 2 Y values that are probably whole numbers that I can compare to. So at my y-intercept and the first immediate dot to the left there, I have a distance of 1 for y there. I'm hoping that's the exact same distance for our new graph, because then that means it's the same vertical stretch. So again, from this coordinate 3 to -2, that's 1 to the left of each other. I'm looking at the y values, that's -3 to -2, that's a difference of 1. So my y values have not changed, so right now I have no vertical stretch. Let's take a look at our x values. So our x values, again, you could take the first 2 immediate dots that you see. So I see -1, 2, and 0, 1. Again, taking a look at our x values, that's only a difference of 1 away. On this graph here, I'm looking at 2, -2, because that's the same coordinate or corresponding, and 3, -3, again, that's the corresponding. And again, looking at our x values, we are also a difference of 1. So right now we have no horizontal stretch. So we have no reflection, no horizontal stretch, no vertical stretch. So that's R and S. Let's talk about T, translations. What do we have? Well, if this 0, 1 is my y-intercept, I'm going to find what area it went to. My y-intercept was right beside something that was to a half and something that was a whole number, so it's going to be this middle coordinate. So I'm basically comparing, how do I go from 0, 1, how do I get from this coordinate to 3, -3? Well, we definitely had some sort of horizontal movement. So from 0 to 3, this is a horizontal translation, and we went 3 to the right. On our y values, we're going from 1 to negative 3. And so that's a vertical translation because our number changed. It's going to be a vertical translation of 4 units down. So overall, my equation for this new function here, and again, we should call it g of x. So let's call our new function g of x there, is equal to, well, again, no reflections, no stretches, so our base was 1/2. X, we did have some horizontal translation movement. We're going to the right, so it's going to be x minus 3. And we went down 4, so it's going to be minus 4. And there we go, and that's going to be our new equation. For the next example, which I believe was below, there we go. We have the graph of y equals 4 of x, and it's translated to produce this graph here below. Determine the equation of the function. And again, my first go-to is to always graph what 4 of x looks like. So 4 exponent x doesn't match up. No, it doesn't. We have a graph that's curving upwards. The question here, it's curving down. So again, let's pull off some coordinates so that we can sketch our graph and compare. So we have 0, 1, 1, 4, and that's pretty much all that we can pull off. Negative 1 1/4, we can definitely try our best to fit that in there as well. So again, I'm just going to zoom in so that I can graph this a bit better. So we have a coordinate dot at 0, 1. At 1, we're all the way up here at 4. And at negative 1, we are at 1/4, so we're barely there. So here our graph, coming in, we're skipping our horizontal asymptote, which is at 0, curving up and up over here. Again, drawing arrowheads because this graph is going to go on forever, just like this one here. So again, just to point out a few coordinates that we used, we have 0, 1, and really we have 1, 4. Those are the only two coordinates that we can try our best to read cleanly. Over here, we only have one coordinate that we can try to read cleanly. That's at 3, positive 1. Down here, you can try to read as well. This coordinate right here, which is about 4 and negative 2. Okay, so from here, let's run RST on this question. So first things first, do we have any reflections? RST. The answer is yes. We reflected it over our x-axis. That's the only way we can curve our graph down. So reflection on x-axis. We don't have any reflection on the y-axis. We only have the 1, or else our graph would be going downwards over here. Do we have any stretches? Let's take a look. So on this one here, between 0 and 1, our x values here, our horizontal stretch is a difference of 1. Between 3 and 4, it's also a difference of 1, so no stretches there. Between 1 and 4 for our y values, that's a difference of 3. Between 1 and negative 2, that's also a difference of 3. So here we have no stretches. Let's take a look at our translations. Well, if we had flipped our graph over the x-axis, so this coordinate would be right here now. So really, we went from 0, 1 to 3, 1. That's our coordinate change. So here we have a horizontal translation of 3 to the right. But right now, with that horizontal translation 3 to the right, we also need to figure out any vertical translations. We definitely have one because our horizontal asymptote was originally at 0. Now our new one's at 2, so we have, because of a horizontal asymptote at y equals 2, we therefore have a vertical translation 2 units up. So overall, our new equation, our g of x equation, is going to be negative, because we have a reflection, base was 4, 3, our x minus 3 there, because we're moving it 3 to the right, and we had to move it up 2 to match up to our horizontal asymptote. And there we go, that's our equation here. In the next example, example 7, it says determine the expression for the y-intercept here. Well, if I ask you to determine a y-intercept, which value, x or y, needs to be 0? For y-intercept, you know x always equals 0. So in this equation here, I'm just going to sub in 0 for x there. So I have y equals 2, c of 0 plus 2 there, minus 1. Cleaning that up, we have y equals 2c squared minus 1. And so if this expression here is now my new y-intercept, so this is my y-intercept, because you have this comma 0, 0 for x, and this expression here for y. In example number 8, we have determined the equation of the horizontal asymptote based on this equation, where c has to be between 0 and 1. My first hint to you is whenever we give you a condition, you should fill that condition. If the condition is between 0 and 1, the first equation I use, or the first c value I'm going to use, is 1/2. I'm going to go straight to my graphing calculator, retype in this equation, but with a c value of 1/2. So I'm going to go 1 divided by 2 for my c value, exponent x minus 1, and then of course we have our plus 2. And let's take a look at what's happening to our graph here. So if I hit graph, and there we go, that's my curve. Again, you could test multitude, you can test a few different ones if you really want to. So if I had 1/4, because that's a quarter and that's a good one to use, x minus 1 plus 2, let's compare graphs, let's see what's happening. And there we go. So we have both graphs, they're both curving away at y equals 2 there, so we definitely have a horizontal asymptote to work with, and that's pretty much it. So it says determine the equation of the horizontal asymptote. So because of both graphs are curving away at 2, so we know our horizontal asymptote is at 2. So we can say, because we have a vertical translation 2 units up, because that's this one here, therefore our horizontal asymptote will be at y equals positive 2. And we're done. For number 9 here, it says determine the range of the function. So again, if I gave you a c value, you want to try to graph that in. So the very first thing, again, I go straight to my calculator, and I'm going to use a c value of -1/2. So I have negative bracket 1/2 exponent negative x minus 4, and that minus 4, don't forget to hit 1 to the right, minus 4 there. So there we go, that's my graph here. And let's determine the range. Well, how low do you go? Well, the low is the negative infinity. How high do you go? It looks like we're skipping a value. That value seems to be -4. So this was my graph, and based off of my graph here, my range is going to be as low as -infinity, as high as -4, not including -4 because we have a horizontal asymptote at y equals -4. So that's why we cannot include it. This concludes our lesson. If you have any questions about lesson 2, please feel free to ask.